we are going to take a look at the Tekton pipeline used to build, test, and deploy the image for our Java app. Our pipeline has the following tasks. First, a clone task to clone the source code. Then, we use a task that will execute the Maven wrapper to clean the target directory and then compile both our code and our test code. After completion, it will run 3 tasks in parallel. One for generating the name and tag strings for naming the image, one for unit test, and one for integration test. For the image naming, I have set up the Git commit ID plugin in the application spawn. This generates a git.properties file in the target directory that we can use to extract some information. We generate one tag name with a semantic versioning that could act as a latest tag. Using the semantic version, the build time, and the commit ID, we generate another tag which is the one I actually use in the GitOps repository. When the previous tasks are all successfully executed, the buildpack task will run. This is where our image gets built and pushed to the image registry. Using buildpacks releases us as developers from having to write and maintain Docker files. By looking at the source code, it will detect which type of image it needs to build. We will use the Tekton Buildpacks implementation bundled in the Tekton Buildpacks builder, which is the one Spring Boot Maven plugin uses when we tell it to build the image. This builder applies some smart modifications to the resulting image, like installing a memory calculator that will configure the JVM memory based on the resource available to the container at runtime, or reducing the default number of threads if it detects a reactive web app. Finally, after the new image has been successfully pushed, there is a last task that will update the deployment descriptor in our GitOps repository. This could be a Kubernetes deployment CRD, but in this case it will be an Argo rollouts descriptor.